Question 7. The Atomium in Brussels is one of Belgium's most famous landmarks. It consists of 9 identical spheres, which are just balls, as you can see there in the diagram, joined by two types of cylindrical pipe. Okay. So part A, the Atomium is modelled on an iron atom that has been magnified 165 billion times. Given that a billion is 1,000 million, write 165 billion in this form here, a by 10 to the power of n. Right, so 165 billion is 1,000 million, so I have 165, that'd be 165,000, that's 165 million, and 1,000 times that would be another 3 zeros, that's 165 billion. But they want it in this form here where a is going to be a number between 1 and 10. So we'll put our decimal point in here, 1.65, right? And then we're going to have to multiply 1.65 by 10 to the power of something. Now we've moved the decimal point, you see, to get to here. We moved it 3, 6, 9, 10, 11 times. So we put 11 up there. So tidying that up a bit further is equal to 1.65 by 10 to the power of 11. So that's a scientific notation method really of writing 165 billion. Then we're moving on to part B, and they tell us that the diameter of each sphere in the atomium is 18 meters. So the diameter is the distance across the circle or across the sphere through the center, and the radius, it would be half the distance across, so that would be the radius. So that's the diameter. So the diameter divided by 2 equals the radius. So 18 divided by 2 gives us 9 meters, and that would be our radius r. r equals 9 meters. Part 2, find the volume of each sphere. Well, the volume, we need the volume formula. If you can't remember it off the top of your head, it will be in the log tables. The volume equals 4 over 3 pi r cubed, r being the radius, which we've just worked out. So that's 4 over 3 multiplied by pi multiplied by 9 to the power of 3. We'll bang that all into the calculator, taking care while doing so. So first of all, we 4 over 3 multiplied by pi, so shift and down below there to get the pi key, multiplied by 9 to the power of 3, and press equals. We get 972 pi. Now they want that to 2 decimal places, so we'll press the SD key here, and that gives us 3053.628. Now they wanted the 2 decimal places. The third decimal place contains an 8, which is 5 or higher. If it's a 5 or higher, this guy goes up by 1. So that gives us 3053.63 meters cubed, because it's volume. Next up, find the combined surface area of all 9 spheres in the atomium, correct to the nearest meter squared. Okay, there's 9 spheres. Well, the area of a sphere, there's a formula for that, right? That has to be the amount of surface area, say the amount of wallpaper or paint it would take to cover the sphere. The area is given by this formula, 4 pi r squared. Now we've 9 of them spheres, so when we get 1, we'll multiply our answer by 9. And that's all we do. And we'll just plug it in we had 9 there, 4 pi times 9 squared times 9. Bang that all into the calculator, and we'll get an answer for our, what are we looking for again? Area. So 4 multiplied by shift pi multiplied by 9 squared multiplied by 9 again because we have 9 of them, first equals. And again we have this in terms of pi. They're looking for the answer correct to the nearest meter squares, which suggests a decimal type answer. So press ST, and we can see that that's 0.88. That 0.8 will cause this guy here to go up by 1 digit. So plus 1 there gives us 9161. 9161, and we're dealing in squared meters because it's area. Turn the page over now, and we're looking at part D. Each of our 8 pipes extending from the center sphere has a radius of 1.65. So R equals 1.65 meters. That's a radius of our sphere, and a length L of 23 meters per cylinder. So they're asking us here to find the sum of the curved surface area of all 8 pipes. Well, the curved surface area of a cylinder, we need a formula for that. And the formula for the curved surface area of a cylinder is 2 pi RH. So that'll give us the curved surface area of one cylinder, but we have 8 of them, so we'll be multiplying that answer by 8. So we'll just fill in the numbers. We have 2 multiplied by pi, multiplied by the radius 1.65, multiplied by the length 23 meters, and we multiply that answer then by 8 to calculate the area of all 8. So I'll just take here, enter that into the calculator. 2 times shift pi times 1.65 times 23 times 8. And I get my answer in pi again there because I use the pi key. Press SD, and I get 1907.57. Now to the nearest meter, that's going to be 1908. 1908 square meters for the surface area. Moving on, we're looking now at the other 12 cylindrical pipes. So these are different, and they connect the outer spheres to each other. Each pipe has a radius of 1.45. All 12 pipes are equal in length, and they're telling us that the sum of the curved surface areas is 3170, right? So we have 12 pipes, that's 12 times the curved surface area. 12 times the curved surface area equals 3170 square meters. And they're telling us that the radius is 1.45 meters. Now the formula for one pipe for the curved surface area we've seen above, the formula was 2 pi RH. So 12 times 2 pi RH equals 3170. We know what pi is, we know what R is. It's 1.45 in this question, so we can say that 12 multiplied by 2 times pi times 1.45 multiplied by h equals 3170. And this is where we have to do a little bit of algebra. All of this stuff here stuck together, 12 multiplied by 2 pi multiplied by 1.45. We can divide both sides by 12 by 2 pi by 1.45. And we've divided both sides by the same quantity, which is 12 by 2 pi by 1.45. And what will happen is on this side we'll cancel everything here, and we're left with h equals this calculation here, 3.3170 divided by 12 times 2 pi times 1.45, and that should give us the length of one pipe, which is h. So we'll put that in the calculator, use the fraction key, 317 on top, and below we have 12 multiplied by 2 pi times 1.45 press equals, and again we're looking at the nearest meter. We have 28.99 on the calculator, So that's 29 meters. That's the length of one of those pipes. Lastly, part 3, the curved surface area of the 20 pipes and 9 spheres are covered in stainless steel, and stainless steel costs €70 per square meter. Use the areas you have calculated or have been given above to approximate the cost of the stainless steel required to resurface the atomium. So we have 12 pipes of one type, and those 12 pipes have a surface area of 3170 square meters. Then we had 8 other pipes, and we had calculated the sum of the surface areas of those pipes to 1908 meters squared. So these are the surface areas. And then we had the we had the spheres. The combined surface area of all 9 spheres, we worked that out to be 9161. So we had 9161, and this was the spheres, the surface area of all the spheres. So this is the total surface area. So we'll add these 3 figures together. So to work out the total area, we'll just add these 3 figures here together. So we have 3170 plus 1908 plus 9161. That's our 3 figures. So our total area of material is 14239 square meters. And we were told that the steel there cost €70 per square meter. So we used our areas to find the approximate cost. So it's going to be €70 for each one of these square meters. So we multiply this figure by 70 to get the cost. So we have it there on the calculator, 14239 multiplied by 70, and we get 996730. So that is euros, 996,730. So approximately $1 million.